Hello, everybody. My name is SERTUÐ KAPTAN. Today, I'll talk about comparison of load balance algorithms using Cloudanalyst simulation. This study was done by me and ERSİN ÇAağLAR. Let's start reading our paper. Let's start reading our presentation. Here are our contents. We have an abstract, an introduction, a literature review, the proposed model, results, and then for the last part, we have a conclusion that we're going to come up with. So let's start with our abstract. Information technologies have been advancing rapidly over the past decade with new developments happening almost every day. One of the newer technology used in our era is cloud computing, developed by major companies in order to supply the user's demand. Cloud computing is used in almost every field that provides people services over the internet. Cloud computing can be summarized with cloud computing is a technology that delivers users the resources for the services they're demanding. These resources are held in a place called data centers, and data centers are locations, physical computing resources to provide users in the moment of a demand. These data centers have their own computing techniques, which are as load balancing algorithms, broker policies, and etc. Load balancing is used to balance the workload demanded by the user on the data centers so that data centers do not end up overloading and crashing while users are demanding their services. And here we talk about our introduction. Cloud computing started gaining popularity in 2007 thanks to the exponential development of communication channels, as well as the need of business and organizations to expand their information systems. Cloud computing is a way of giving users and customers access to cloud services with the usage of web tools. Cloud computing services have load balancing algorithms as well as broker policies to perform better with the consumers that are trying to access these services. Load balancing algorithms act as a guide for user requests in order to get better efficiency while connecting to the data center. Load balancing algorithms can also help when a data center goes down, and by routing to a different center that can handle these requests, we can prevent a crash. Depending on what service broker policies and load balancing algorithms, users can connect to the services faster and also have a faster response from the service. Let's talk a bit about our literature review. Before this paper, there have been different comparative studies in this field about load balancing algorithms in cloud computing. We have two examples here, but there has been more studies that has not been shown here, but we'll only talk about these two. In the first example, this study was done by comparing load balancing algorithms as well as changing the broker policies to observe the best combination. In our second example, authors of the paper have tried comparing the load balancing algorithms while implementing Facebook's user population for each region. A study was simulated by using Cloudanalyst. And let's talk a bit about our proposed model for our paper. Purpose of this model is to compare load balancing algorithms by iterating data request size from 100 to 5,000. Increasing the request size will increase the load for each data center, which can be used to compare the performance of the load balancing algorithm. And as it can be seen in the figure, Cloudanalyst was configured to have data centers and user bases for each continent and each region. In the table below, the configurations used for user-based modeling can be seen. However, data size per request change for each iteration. And we can see our user bases from 1 to 6, and they have their own ID region, which shows our continents, and they have their peak hours, which help them simulate more realistic simulation. And we have their average peak users for each continent, and these were purposely ratioed so that they can simulate the real world. Data center configurations can be also seen in the table below. Server broker policies have been set to closest data centers. Let's move on to our next slide. Each data center's detailed configuration can be seen in the figure. It goes from data center 1 to 6, and they have their own region, which is, like we said, their continents, and we have their physical hardware units. So let's move on to it. Each hardware unit is a replica and has been configured to be same and equal, which can be seen on the screenshot. They go from 0 to 20, and as we can see, they have their memory, which is in megabytes. We have the storage. We have a number of processors with processor speeds and virtual machine policies. Let's move on. And we can see in here the advanced part of the simulation. Load balancing policy is included in the advanced part of the configuration, which is one of the main purposes for the simulation. And we can see it named as load balancing policy across virtual machines in a single data. This helps us figure out which load balancing algorithm is going to be used for each iteration. And as you can see in the example, it is equally spread current execution. And let's move on. And here are our results. And as we can see in the graph, it shows the overall response time between the load balancing algorithms under different loads. And as you can see, the yellow is location aware. And it is slightly performing better than the rest of our load balancing algorithms. So let's move on to our second result. The graph shown is a data center processing time, which shows how fast a data center processes a request and then executes. And we can see there's a landslide between the rest of the algorithms and location aware. It has a better and significantly greater data center processing time, which makes it the best among all. Let's move on to conclusion. In this paper, after observing the importance of load balancing algorithms, they have been put into simulations to test which would give out better results and under what circumstances these results would be better. After configuring the simulator, which is Cloudanalyst, and running it, the results were recorded as well as observe. After observing the results from the simulations, when it comes to data center processing times, location aware is the best load balancing algorithm. And this trend can also be seen on the overall response time, which means location aware is the best load balancing algorithm also for overall response time. However, as we can see in the previous slides, in the previous slide with the results, when the data request size were increased, load balancing algorithms started behaving the same and giving out quite similar results. And for our main conclusion, this reveals that location aware is the best when it comes to lower data request size. But when the request sizes is increased, all of the load balancing algorithms will start equaling the same speeds and rates, like I said, previously seen on the results. This means that load balancing algorithms only matters when it comes to low data size, because the bigger the data size, the more they're going to be starting to equal to each other. And thank you all for coming to my presentation and for listening to me present this paper. And I hope that you all have a wonderful day and enjoy the rest of the presentations. Bye-bye.